Alright, we're wrapping up 3.5 here. We'll do one more example of sketching. We left off, I did one example in the previous video, we'll do one more in this video. Then I'm going to show you an example of how to find the slant asymptote, also known as the oblique asymptote. Alright, so I listed our steps up here on how to sketch the rational function, and then we have the rational function that we want to sketch here. So let's just get started. Alright, we're just going to follow our steps. So I told you in the last video, I generally just write out a list over here and start filling in stuff. Step 1, find your intercept. Well, to find our x-intercept, we'll plug a 0 in over here, and you'll find that x squared equals 0, which of course tells us that our x-intercept must be 0. Y-intercept, plugging 0 in for x's, 0 over anything, of course equals 0. The next step says to find the vertical asymptotes. We find our vertical asymptotes by finding what makes the denominator equal to 0. So in this situation, we just factor the bottom, it's a difference of squares, and we find that our vertical asymptotes are plus or minus 2. The next step, find your horizontal asymptotes. We had some rules in the last video, I believe, that told us how to find these. One of the rules was if the exponents of an and bm are equal, then it's just the coefficients of an divided by the coefficient of bn, which in this case is just 1 divided by 1, which is 1. Alright, last step would be to plot additional points. We'll do that at the end of the video. So now let's just sketch it. I think I told you in the last video, it's easier to start by sketching your asymptotes first. So we'll sketch our vertical asymptotes, followed by our horizontal asymptotes. And you can see the vertical asymptotes divide this graph up into 3 regions. We've got region A, B, and C. The next step would be to look at your intercepts and start graphing. Well, we know our x-intercept and our y-intercept is 0. So we know this point has to be on the graph. From that point, plotting points, which you can do on your own, will show you that the center of this graph is a parabola, opening downward. The next step is to find out what happens in region A and region C. Again, plotting points and then using your asymptotes, you'll find that the graph looks something like this, with a branch on each side. Alright, so you get all the information you can out of this stuff, and then to finish it out, you're just going to have to plot a couple of points. It's not difficult. Pick easy points to plot on each side, and then use the asymptotes to show you where to go from there. Alright, let's look at some oblique asymptotes. Let me give you a definition first. A slant or oblique asymptote is a line of the form y equals mx plus b. So a slant asymptote just has the form y equals mx plus b. It goes through your graph. It serves the same purpose as a vertical or horizontal asymptote does, just looks slightly different. Right? So it has the form y equals mx plus b, such that the graph approaches this line. So we'll look at one example. Let me make a note here. I'll write it right here. This is important to recognize. Slant asymptotes are not common, and this will help you know when to look for one. A graph can only have a slant asymptote if the degree of the numerator is 1 greater than that of the denominator. Okay, so this is an important note when we're talking about slant asymptotes. We can only have a slant asymptote if the degree of the numerator is 1 greater than that of the denominator. So let's look at an example on how to find a slant asymptote. We're not going to graph it or anything. I just want you to know how to find them. Graphing them's easy because it's just a line. So we'll look at an example on how to find it. All right. On a test or something, I would say show that this function has a slant asymptote, and then find it, or something along those lines. So our function is f of x equals x squared minus 9 divided by 2x minus 4. First thing to check, does it meet the criteria that we wrote down here? Is the degree of the numerator 1 greater than the degree of the denominator? The answer here is yes. So the next step would be, yes, it has a slant asymptote. How do we find it? And you find it by simply doing long division. So 2x minus 4 divided into x squared plus 0x minus 9. And you guys know how to do this. What do we multiply 2x by to get x squared? Well, the answer here is 1/2 x. Alright, so 1/2 times 2 is 1, x times x gives me x squared. 1/2 x times a negative 4 gives me a minus 2x. So we change our signs here, and you're going to get a 2x minus 9, bringing everything down. 2x goes into 2x one time. So multiply that through, change your signs, negative 5 the remainder. That's not really what we care about. What we're concerned about is this right here, the quotient. This is your slant asymptote. Okay? Remember, it has to come out to the form y equals mx plus b, which this does. This is a line with a slope of half and a y-intercept of 1. So if we were to put this on a graph, we'd go through our normal rules and we'd graph this slant asymptote and see what the graph would look like. We're not going to take time to do that now, but it's certainly not a difficult thing to do. Alright guys, that wraps up chapter 3.5, or section 3.5. We'll move it on, probably skipping to chapter 8.